Good afternoon, everyone. Hope you're having a fantastic weekend, stuck at home. Hope you're right. Hey, look, if you're out and about, if you're on holiday, if you're at the holiday home, screw you. hope you're all staying at home, and hope you're all making the most of a quiet Easter weekend. In typical fashion, the levels in my own headphones are horrible. Hopefully that'll do the trick. So glad you could make it this afternoon. If you need to duck off, if you want to duck off, if you've got better things to be doing, we've all got family we could maybe be given a phone call to or hanging out with if we live with them. Please do. But if you're here and you're happy to stick around, so good to have you here. Word of warning. My machine just feels a bit brittle at the moment. Something's not quite right with it. It's an old laptop, and the battery is like stuck on 0%. I think it's done the chemical thing where it went below 0% and it just doesn't want to charge now. So on one hand, maybe it's throttling the CPU because it just can't get power, or maybe there's something more wrong with it. I've ordered a replacement battery, but I may need to rebuild. But anyway, the point is, it's a little bit slow, but it also feels a bit shaky. It also feels shaky because I had to rebuild my Docker image that has my tills in it because I gave away the password last stream. And I kind of, due to the jankiness of this box, only just got that going about 15 minutes ago. So I haven't really put that image through its paces as much as I'd like to. So all I'm saying is let's see what happens. This might be a bit of a dodgy stream, but we'll do what we can to resurrect it if there's any issues, and just bear with me if there's problems. So with that out of the way, I really want to try and get this CTF series behind us today. This is the third episode of the Elttam Insatiable bird series. We're on the last level. It's a crypto level. For those who missed the first couple, they're up on YouTube. But they're essentially web and crypto challenges in a series called Insatiable Bird. They were created a few years ago for B-Sides Canberra and BrewCon, so some people may have seen them already or played them even, but we're doing them, and we're on the last level, which is a horrible crypto level. We think we know what we have to do, but we'll find out if we can do it today. Was the resurrection of my stream planned to coincide with Easter? Dr. Silvio Cesare? No, it wasn't. Pure coincidence. In fact, it was probably, time to coincide with everyone being stuck inside. A, me being bored out of my eyeballs, and also B, wanting to do what I can to help people feel a bit more connected with each other and have something to do while we're stuck inside for COVID-19 isolation. So if anything, it was more to do with we're all being stuck inside right now. Beer report for today. No beer yet, Barney. Later on, I've got a choice between... I can't even remember which one... what one of them is called. I've got a couple of spare. The one that I'm probably going to be getting into is the modus operandi. I call it the green one. It's like an IPA. It's a modus operandi brew. This guy, the Sonic Prayer IPA, really good drop. Pro streamer indeed. All right, so we got a Dr. Silvio Cesare and we got a Silvio Cesare. Who's who? What have we got here? Dr. Silvio Cesare, account created May 2018. Silvio Cesare, April 2018. How about we let the Silvios fight it out? Which one's the real Silvio? Ban them both. What are we doing? We talked about beer. We talked about the ISO going on. Birdie-indigo. So we got the Birdie-indigo container up and running here. I was just starting burp as I was starting the stream. So let's get burp wired up. What have we got? I would have done this before the stream, but as I said, I had some issues getting things done in time. That proxy. You can just see this machine's just... something's not quite right with it. And also I can't type. Hopefully the battery fixes it, because I just kind of don't want to rebuild it. burp/cert. Save that. I'm going to bring the privacy screen up for just a second while I finish setting up my browser. Yeah, cheers, that wolf. That should do the trick. So we got burp. 172.18.01. There we go. All right, so we've got the last level, the indigo level, up and running. So let's take a quick step through this. Let me just fix up my second machine here. Right, so the goal of this level, as with the other levels, is to log in as admin. So now if we just put in the username of like ZZZ, login, we can see there's a post to /login with username equals ZZZ. In the response, we get back a session data cookie. If we send that to decoder, it looks like this, just a JSON object with the username being ZZZ. And we get back a session hash, which is the length of an MD5 sum, and we're led to believe it's an MD5 hash. We'll get to it in just a second. We also get a redirect back to the home page, and if we follow that redirect and give the home page our 2 cookies, we get told, welcome ZZZ are just a peasant user IC, and we have to log in as admin. Now importantly, if we send this request to repeater, if we change this username from ZZZ to ZZZ2 and send, we don't get that welcome message. Yeah, we'll change it back quickly. The reason being, this session hash needs to be a hash that is valid for the data we're giving. And when you post to /login, you get given these 2 values where the hash corresponds to the data you're being given. And if you go and change the session data, the session hash will be invalid. Now, importantly, we cannot log in as admin. No access for this user. And we don't get given the magic cookies if we try to log in as admin. So essentially the goal is to come up with, Barney, this is crypto. Crypto, medium difficulty. The challenge is to come up with some way of getting let's just go brand new cookie, a session data. We need to get a session data that is some JSON such that when it's deserialized, the application thinks that our username is admin. Yes, Barney, continuing on exactly. I'm just building up kind of where we left off, and also like just paging it in my own head. We need to come up with a cookie that has such that when you deserialize it as JSON, the application thinks our username is admin. And we need to have a session hash that matches this mess of data that we're giving it. So at the end of last stream, I was struggling hard, and I asked Bitcoin CTF for some tips. And he said that what I was doing was on the right track. It was something I was doing that I got sick of trying, thinking it wasn't working, and abandoned. And he said, no, you were on the right track. Keep trying. And what that is it's called hash padding. So we can probably go through what hash padding is. I'll try and do it really, really quickly. We've talked about it 3 streams in a row now, because the first stream we had a level that we thought might have been hash padding, and it wasn't, so I explained hash padding. The previous episode, this level is hash padding by the sounds of it, so I explained it again. This third stream is me finishing off that level. So now, what is hash padding? first of all, we believe that this session hash here is the output of MD5, some secret value concatenated with the, like the cookie session data, right? And the server, by the way, the server will do the URL decode on this for us before passing it to the application. So this cookie, for the purpose of calculating MD5 hash, will be this after URL decoding has been performed. So we believe, or we suspect, and Bitcoin has kind of indicated that we're on the right track. Thanks, Barney. Good on you, jerk. We have a feeling that this hash here is the output of MD5 with a static secret key or value that we don't know. Before I go on, by the way, the source code for this level, it's available because it's all in a Docker image. You can just go and pull the source code out, which we're not doing. But B, the source code is actually published on GitHub. And you'll see that link is blue, and it will be staying blue for me. So the source code is on GitHub, but you're not meant to read the source code when solving the challenge. So I'm not going to read the source code. I'm just running the Docker image that runs the source code, and I'm treating it as a black box. I'm not looking at the source. People on stream, you're welcome to go and read the source code if you'd like to see how it works as I stumble through it. But if you do so, please refrain from giving hints or suggestions or fixing my mistakes or telling me I shouldn't be doing X and I should be doing Y. 'Cause that's kind of, it spoils the fun for the rest of us. We're trying to, I'm trying to do this not knowing what's going on the inside. You're welcome to have a look, but if you do so, just please keep any guilty knowledge to yourself. So this secret's baked into the source code, I'm guessing. And so what we would need to do is we would need, what we want is a cookie session data value, can't even type, that deserializes such that username equals admin, and we need a session hash as per the above calculation, right? And we can do this potentially with hash padding, and we've got quite a few hoops to jump through. We'll get to those hoops in just a second, but for those who may have missed it, what is hash padding? So for algorithms such as MD5, SHA-1, SHA-256, and undoubtedly others, they operate in something called, I think it's like a Merkle-Damgard, and I'm probably butchering that horribly. Hash padding attack. The Merkle-Damgard based hash. It works like this. Let's say you give an input. By the way, I feel like I'm getting better each time I try to explain this. Let's say you give an input of a whole bunch of A's, and you want to calculate the hash. So let's take MD5. MD5, it's like think of it as a machine where you put stuff in and turn the handle. When you pull the MD5 machine out of the box, fresh out of the box, it has an internal state. It's got like a bunch of registers or a bunch of displays on it that show some certain values, hard-coded values out of the box. And every MD5 machine, every time you MD5 hash something, it starts off with the exact same internal state. It's like an initial internal state, right? And what MD5 does is it gets the first block of the input. So let's say, just for argument's sake, that it's like 5 characters. 1, 2, 3, 4, 5. It's not 5 characters, but as an example, get the first block. 2, feed it into the machine. 3, turn the handle. And in turning the handle, the machine kind of like chews up and eats up those 5 characters. 4, the state gets mutated. So all those registers inside the MD5 machine kind of like click over. Depending on what the 5 characters you put in were, the machine will just kind of like scramble its numbers in a predictable way as per the hashing algorithm, right? 5, get the next block and go to 2. right? So the machine will then get the next 5 A's, put them in the machine, turn the handle, the state gets mutated again. Get the next 5, put it in the machine, next 5, next 5. And then you get to these last few characters here. Now, the last few characters you're putting into the machine isn't a full block. It's like just the leftover characters. I mean, maybe your input was a perfect multiple of the block size of MD5, but it's probably not. And if it is, let's put that case to the side for a second. That last partial block needs to be padded before it can go into the machine, because the machine only takes full block sizes, right? So 6. For the last block, it gets padded. And padding looks kind of... There are algorithms, and MD5 will prescribe which padding algorithm should be used for inputs into MD5. An example padding algorithm would be... And just... MD, like the stuff we've done so far, it looks kind of like this. We don't need to know the details, but the padding algorithm looks something like this. It's like hex 80 plus hex 00 times n, you know, enough null bytes to kind of get you to nearly a full block size. And then it's like plus a hex like a binary representation of the number of bytes of padding. So the padding is like self-descriptive. A padding sequence tells you how many bytes of padding are in itself, so that you could kind of like remove the bytes of padding if you ever needed to, and you would know exactly how many bytes to remove, because it's very likely the message you're hashing contains hex 80 and a whole bunch of nulls before the end of the message, and then you'd be like, well, how many of these are the padding and how many of these are the actual message? Well, the padding tells you how many bytes are in the padding, so you can remove exactly that number of bytes. Anyway, you can kind of like treat this as a little bit of a black box. We don't need to know exactly how it works, but you'll see binary data that looks like this sort of gibberish. It's padding. Just helps you, I guess, realize why it's there. So anyway, that's how MD5... Oh, and then 7, you know, you're done. The hash is the final state of the machine. You know, the state after this last block has been padded, and then the handle turned, and then the registers mutated. The state of the machine is the hash. Like, that's how you get a hash. You just read the state of the machine at the end and you're done. So that's how to do hashing. Like, that's a rough explanation of just how it works. How to hash extend or pad or attack. A hash extension attack or a hash padding attack. Step 1. Get the hash. So, you know, we can see hashes here. The application is telling us for some secret we don't know, plus this here, plus enough padding to take it out to a multiple of the block length. When you hash it, this is the hash. So it's like, cool, we'll get that hash. And then number 2 is like you fiddle the dials on the MD5 machine to set its state to the hash. So you basically get your own MD5 hashing machine, and you just crack it open and you fiddle all the registers and you set the registers to the hash you're given. 3, you put more data in the machine. 4, see above as to how hashing actually works. You put all the blocks in of your extension to the message and turn the handle. 5, the new hash is the new final state of the machine. So it's kind of like picking up where the original hasher left off. You take the original hash's hash or machine state and put your own data in and turn the handle, and what you can generate is the MD5 of the server-side secret plus your data, you know, your let's not say your data, plus the session data, right? This stuff here, plus padding noise is all this horrible garbage from padding, a bunch of noise, plus your, I guess you could call it your appendix or your extension to the message. You can calculate the MD5 of that without even finding out what the server-side secret is. So that's how hash padding works. And we got to the stage at the end of last stream. Actually, let's just flick over across now to Twitch, Elttam, Indigo. Haha, my new Docker image has the needful so that these VMs just work. We had trouble with that last time. So we've got this script called brute. No, not brute. Pump? Yeah, we've got this script called pump, which pulls in something called hash pumpy. Hash pumpy is a Python library that then is a binding for a C or C++ program called hash pumpy that basically automates this part for us. Right, so we will give hash pumpy the session data. We will give it the extension to the message. We will give it the original hash, and it will kind of, if we knew how long the server-side secret was, our hash pumpy script would be easy. But because we don't know how long this is, hence we don't know how much padding noise the server-side hashing machine had to put in to take the input out to the multiple level block size, we kind of have to guess how long this padding noise is, which is why I've got this busy for loop here that just tries all the possible values of how long this secret could be, hence guessing how much padding noise the server put in when producing this hash for the first time. So hash pumpy then will return, you'll see it in a second. You'll see it in a second when I run this script. So we're doing a loop for all the possible lengths of the server-side secret, and we're using hash pump, and we're giving it a original hash, which we'll just get some fresh hashes and put them in a second. The session data, what we want to add to the message after all that padding wheeze, and hash pumpy is giving us the new hash and the new username, and then we're just basically throwing it at the server. Ooh, that's dangerous. I don't need that line there. Ooh, that's something we were trying last stream that we decided wasn't going to work, I think. So I don't know why that was still there. Whoops. So for all of these 256 different possible hashes and usernames that we're pumping out from hash pumpy, my script is trying to access this script is awful. My script is trying to access the homepage of the victim application, giving it the 2 cookies that we've generated, punching it through burp, and on its way, it's just printing out the SHA-256 sum of the page we get back from the server. And that's just a really hacky way that I'm trying to see whether any of the attempts we're making against the server give us a different page back, which means that we have a session data and session hash that have resulted in us logging in as someone and hence getting a valid session as a user we shouldn't have. That's where we finished off last stream. And Bitcoin CTF was explaining to me, I had a faulty assumption. I was assuming that if I was able to cryptographically punch out a valid session data and session hash that had some illegal JSON in it, that the server would blow up with like a HTTP 500 response. Turns out there's error handling on the server, and if we give it invalid JSON, it just gives us that login page. And Bitcoin was basically saying, try deserializing something using your own Ruby program, because the server in this case is written in Ruby. try deserializing some JSON that has some null bytes in it. And I did that, and things blew up, and Ruby doesn't like deserializing JSON with nulls in it. And then Bitcoin and CTF said, figure out how to trick Ruby into deserializing JSON with nulls in it, and nulls have to be in our JSON because that is all that padding noise we were talking about a second ago here. And Bitcoin said, once you figure out how to get Ruby to be happy with JSON with nulls in it, you should have this. That is the long-winded explanation of where we left off last stream. So for everyone who was here last stream, thank you for sticking around with me through that. That was important for anyone who wasn't here, but also important for me, so I could page all this back into my lump of squishy brain. So that was a lot of talking for me. I'm going to just take a quick 1-minute breather to catch my breath. After that, we'll be back to figure out how we can get Ruby to accept JSON that has nulls in it. Thanks for your patience. I'll be back in a second. Alrighty, we are back. So Barney has pointed out I've just opened it up outside my streaming VM because I still don't have clipboard synchronization working with my VM. Barney's pointed out what looks to be a Ruby library that has JSON parsing that can parse nulls. And dude, I don't think that will help us in this case, because we might be able to get our local Ruby parsing JSON with nulls in it, but that won't necessarily help us with the server because we don't get to tell the server use a library that will happily parse nulls. We might very well get our own Ruby parsing nulls in JSON, but kind of won't help us trick the server into eating a null. So I've been thinking about this the last couple of days, and I think what I'm going to do is build a small Ruby program, being not a Ruby programmer, that will be interesting. Build a small Ruby program that takes JSON on standard in, tries to JSON decode it, and tells us either yes or no that is decodable or not. It will if you edit the Docker container. Denied. What will that do? If I build a Ruby program that will take JSON, or even better, base64 encoded JSON, so I can have nulls passed in without worrying about escaping them, I can then sit fully outside of Ruby and script a Python loop that will essentially fuzz Ruby to try to find a way to get nulls past the problem we're having. Essentially, you can tell I'm A, lazy, and B, don't really fancy doing Ruby, and I'm trying to get myself out of Ruby as quickly as possible. If we can build a small Ruby program that tries the JSON decoding stuff, we can then step outside of Ruby and just start throwing stuff at it from outside of Ruby, where I'm more comfortable writing fuzzing loops and mutators and stuff to try and figure out the trick, because apparently it sounds like there's a weird trick that will let us have these nulls in our JSON payload. So that's the direction I'm thinking of going. But before we do that, I've got one last thing I haven't discussed yet, which is what I'm doing here. So now let's log out of this. If we log in as, ZZZZ, and we get what that cookie looked like, send to decoder, decoder as URL. If we hash pumped and hash extended this, right, we would get all that padding wheeze, and then we could put in our own stuff. I'm just going to go Y for the stuff we can control then. Like, the nulls aside, that is so far from legal JSON, it is not funny. We decided last stream that our best bet is to leave the JSON we get back from the server, and hence get a valid hash for, what I call dangling. We want to leave that JSON dangling in a context that it will possibly be safe to use these characters in. And the way that I thought to do that was what's interesting about this app, by the way, is we get what I call JSON injection. So if we just log in as, you know, ZZZ, actually, by the way, there's a length limit here, 1, 2, 3, 4, 5. We can only put 5 characters in this form, and hence we can only have 5 characters in here for which we get a valid signature back for. So if we put in like AA double quote BB and log in and have a look at what we got back from the server, let's send this to the old decoder. You'll see that our double quote in the middle there, it survived. You know, if the server was doing the right thing, it would be dropping a backslash in front of that double quote so that our username was AA literal double quote BB. But without that double quote, without that backslash, this is now illegal JSON. So we get the ability to use like JSON meta characters in our username, which means that if we log in as a username with a single backslash, the JSON we get back from the server is this. So the username as a key, we close those double quotes, colon, the value of the username is open the double quotes to start a string, backslash double quote, like a literal double quote, an escaped double quote, curly, and then it's like the JSON parser will be like and then, oh, that's the end of your JSON string. That's illegal JSON, right? But what this now lets us do is we're left dangling in this string context here. So we can bring to the party all the hash padding that hash pumpy gives us, y, our own message, and end our own message with double quote to close off this double quote here, curly, and that is now once again legal JSON, and we managed to trap all this padding here inside that string. The issue being, Ruby chucks a fit when it tries to deserialize JSON that has hex 80 or null bytes. I think it's the null bytes it's really unhappy about. Ruby chucks a fit when it sees that. But you know, with this little backslash trick, we managed to leave ourselves in a dangling JSON context in which we have the best shot at producing a hash padding attack that will be deserialized. And at this point, our username is double quote curly, line noise, y, but if as part of our hash padding, because we can now use more than 5 characters because we're offline maliciously generating a valid hash, we can insert, I'm guessing we put in a new key, username being admin, and I'm guessing Ruby, we can check this, we can validate this, but I'm guessing Ruby's going to take it's kind of like the old HTTP parameter pollution attack. Ruby should hopefully pick up this second username being admin and use it to overwrite this username of line noise. And we can test that with our harness that we build in just a second. So, you know what? We can probably come back to this whole hash pumping stuff soon. We should probably determine. Actually, you know what? No, I won't do that. I will do this now to show in burp what a hash padding attack looks like. So with our username being the single trailing backslash, this hash here matches that hash here. So I like the look of that. So let's just run our pump script. No module named hash pumpy. I think it was I think the princess was in a different virtual environment. Was it silver? bin activate /pump. Nope. Let's deactivate. Let's just recreate this virtual environment. Python 3 vn. And then we'll activate that virtual environment. And then we'll pip install, pip3 install, hash pumpy. And at Wolf, you'll be happy to know that I put Python dev tools in when I rebuilt this this image. So that's the cool thing about having your own Docker image that has just the tools in it, nothing else you need. You kind of, over time, you learn what you need to make it just right for you. And you can refine it over time and reorder stuff and put new tools in, take old tools out. Wolf is waiting for the fail. One step ahead of you. So now we run pump. No module named requests. Pip install. Do I need to do pip 3 or I don't know? Probably not, because I did Python 3 virtual environment. Pip install requests. There we go. So all these hashes are all the SHA-256 sums of all of these responses here, with the idea being later on, if one of these hashes changes, one of these responses came back different. Thanks, guys. So this is what a hash padding attack attempt looks like. And the reason why we're having to send so many off is because we don't know how many... Why is that encoding in there? I thought I just got rid of that. Save that, run it again. That's better. I like the look of this a little bit better. I think I like the look of this a little bit better. The reason why we're sending off so many requests is because, as I said before, we don't know how long the padding was in the original generation of the hash, so I'm just throwing probably way more attempts against the wall than I need to, and hoping one of them sticks. So now if we just send this session data to decoder, decode it as URL, it looks like this. We've got the username, it looks like a double quote, colon, double quote, backslash, double quote. So this here is the starter string. That's a literal double quote. 7D is the curly brace. And then 80, 000000000. This is all about padding. 3802, 000000079. So the 79797979 is our YYYY. So the bit I've highlighted here, that's what padding looks like. And we think that Ruby is just totally blowing up when being told to deserialize JSON that has null bytes in it. YYYY. This 22 is a double quote, which terminates this double quote here. So that there is a string with the double quotes surrounding it. And then the 7D is the closing curly for that 7B. There you go. I don't like the way it's highlighting, but yeah, 7D right there, 7B. So it's, I think, legal JSON, except for the fact that we've got line noise in the middle that is making Ruby really unhappy. So we want to try and find a way to trick Ruby into accepting JSON that has this wheeze in the middle, keeping in mind what we can do to maybe make it more ready for that wheeze. We could maybe encode it, but I don't think encoding is the answer, because I think that'll break the hash. But the other thing we can do is we've got 5 characters here to play with that might, like, I don't know what we could do, whether we close the value context we're in and put ourselves in a key context and put a backslash there. I don't know. We've got some characters here to play with, though, to prepare Ruby for what it's about to see. Or maybe I'm just way off and we'll be here for many, many hours again, going down deep and dark rabbit holes. So, how do I Ruby? Let's create a file. Deserialize b64 encoded json.rb. That's what we're going to produce. We're going to produce what I call a harness. I don't know if that's the correct use of the word harness, but a small bit of code that basically takes either as argv1 or as standard input. I haven't decided yet. argv1's probably simpler. Takes base64 encoded JSON decodes the base 64 and then throws the JSON at its parser and then tells us whether it was successful in decoding it or not, deserializing it or not. And it might be nice to get it to tell us what it deserialized as well. What do? I have no idea. Use a bin env Ruby. Is it puts hello world? Are there semicolons in Ruby? I don't even know. Chmod u plus x that, and then run it. We got hello world. That's a good start, right? So from last time, I think we used require JSON, and we were doing like puts JSON dot, I think it was JSON dot parse hello world, run that. So that's good. We've now got JSON parsing happening. I think we were doing require base 64. We were doing all this last time, if you missed it, by the way, in like IRB, which is a Ruby REPL. Yes, Barney, there are birds outside, so you'll get a little bit of a taste of nature during the stream. IRB is like a Ruby REPL, which means we can just do stuff here like puts 1, 2, 3, 4, and it'll do it immediately. So we're just taking what we were playing with last stream and formalizing it in an actual script. I can't remember what we did for base 64 last stream. Ruby base 64. So we require base 64, and it's base 64 with a capital B dot decode 64. We already had it. Let's do puts json.parse base 64 dot decode. Is it decode 64? Yes, it was. The encoded value. So now let's just quickly echo hello world into base 64. Grab that. Right. So this should now unwrap the base 64 and then do a json.parse. We should get the same as before, hello world. Cool. Almost there. Ruby argv. How do we get stuff from the arguments? I don't want Code Academy, just give me something short and simple. Let's go Code Academy, fine. Come on. Okay, so argv is just magic, it just works, I think. And we can, I think, what... Yeah, how can we unpack? Okay, so we can do first arg, we can unpack it and just do star the rest equals argv, and it'll just take the first argument and throw away the rest for us into the rest. Would stood-in be better serializing me? Yeah, maybe. I mean, if we took stood-in, actually, you know what? If we took stood-in, we could fuzz this with line-separated base 64 encoded stuff and run the loop inside Ruby to do like for each line in stood-in, do the unwrapping and the deserializing. I like that. Let's do that. So it looks like for future reference, you can unpack argv in Ruby with magic like this. Yeah, let's do stood-in. Ruby stood-in. Yeah, Men's will probably end up doing something like that. Probably do something like that. Frame drops, hey. I have 0.1% dropped frames going on my end. 97 frames have been dropped. So quite possibly my mistake. I'm still going up over 4G. So if there's frames getting dropped, maybe next stream I can try and reduce the bitrate. But apart from that, there's not much I can do, sorry. Other people are saying it's okay, so we'll power on. Apologies, Atwolf. But you know what? It's probably your connection anyway, am I right? How do we, in Ruby, let's just Ruby stood in for each line. Kind of like the look of this. Hash dollar underscore. Yuck, Ruby, yuck. So text is stood in dot read. Lines equals text dot split on the new line. For line in lines do. Puts a number. We don't care about numbering the lines. Plus line. Done. I'm stealing this. Yeah, okay, good call, that Wolf, good call. Plus, I can't afford to do parallel encoders on this old crappy battery dead machine, so whatever bitrate I put out onto Twitch also gets spooled to disk, and that's what I then chop and change in DaVinci and render and push out to YouTube. So the lowest common denominator determines what bitrate we're getting at the moment for both the stream and YouTube. So text is stood in dot read. This Ruby's probably making people cringe, but oh well. Don't need the I, don't need the I. Let's put an indentation here. Don't need this. So for line in lines, do puts line. Let's go and just do, instead of that, instead of putsing the line, we'll puts json.parse base64.decode64 line. And let's just do puts, let's do it afterwards, puts some dashes. And we still need to put some error handling around if either of these blow up, but we'll get to that in a second. Barney says, have you got fiber to the premises? No, I do not. Barney, I'm on HFC here, and it's not a... I won't throw anyone under the bus, but it's not a good ISP doing it at the moment. But I'm here for now, and if I stay here for much longer, I'll change that myself. But for now, I'm just dealing with HFC and an El Cheapo ISP. All right, I like this so far. So now we can go echo hello world into base 64. To wrap these in round brackets, so we can go hello world into base 64, echo hello 2 1 2 3 4 into base 64, and we get 2 lines of base 64 output, and we pipe that into the deserialized script, and there we go. Stood in was a good call. We can do multiple things at a time. The first one comes out to hello world, the second one comes out to hello 2 1 2 3 4. Atwell says, will my area get HFC NBN? We're on HFC NBN. Yeah, we're on HFC NBN right now, is what we're on. But it's just not a great ISP. It's on the 50 down, 20 up, I think it is. You know what? You can figure out which ISP this is based on this. 50 down, and they don't advertise what they're going to give you up. And I'm getting like 2 megabits per second up. Hence why I'm on 4G. So they don't commit or advertise any sort of upstream bandwidth. Go spelunking and figure out who they are based on that. Don't say it in chat, please, if you figure it out. But yeah, a new ISP would go a long way, I think, towards making the HFC here more livable. Cool. We've got a little harness. Now, if we go and break that first JSON and take that double quote there off, what happens? Ruby blows up because it gives a JSON parser error, and Ruby doesn't bother trying to deserialize the second base64 encoded bit of JSON. We don't want that. We don't want this script to blow up as soon as it has an issue. We want it to politely tell us it had an issue and then move on and try subsequent test cases so we can start to fuzz this without having to restart the process. How does error handling even work in Ruby? I don't know, to be honest. Does it have exception handling? I don't know. Ruby exceptions, Ruby learning, geeks for geeks. Yeah, fine. Turns out I typoed handling, by the way. Oh well. Yeah, if that's to be by any cheers, I will. If I make a change and I think I need help, I'll reach out. So Ruby can raise exceptions. Just does raise and then some string. There's probably some way of actually raising a particular exception in Ruby. By default, it's a runtime error, but otherwise you can raise an argument error and say whatever you want. Cool. Handling exceptions. This is kind of more what we want. So we do begin, and then if there's a raise inside the begin, we have a rescue after the begin, and then we have an end. So when you run this here, it'll put I before the raise. There it is. This raise, an error has occurred, gets kind of swallowed by this rescue, and inside the rescue we put I am rescued, and then we end this begin block, and then we put I am after the begin block. And what's cool is if you rescue an exception and swallow it, the script keeps running. Begin. The more Ruby I see here, the more I'm glad I didn't bother with. Yeah, I'm sure it's nice. I've got really good friends who love it. Bitcoin CTF being one of them. But I'm pretty happy with my Python, my terrible Python. I'm sure it has its good sides, and I'm sure its rough edges. There are reasons, methods to the madness, and ways to live with it and whatnot. But anyway, okay. So for line in lines do, I think we should do a begin and an end. A begin, a rescue, and an end. You know what? I want to get some more test data first. So we got this here. So we got a JSON parser error. That's the type of exception. I mean, we've got two options. Either we can, in our rescue, we can only rescue JSON parser errors, or we can do the Pokemon style and catch them all. We'll have a think about that. Maybe we'll just catch them all and complain and try and be as verbose in our complaining about what went wrong and move on with life rather than catching all the different types of exception. Terrible way of doing software engineering, but I'm a terrible software engineer. What happens? I'm guessing we get... Let's get one of our bits of JSON here with the two equalses. Echo minus n. No, we don't need the minus n. Let's get rid of one of those padding equalses and pipe that into our harness. What is our harness called? Deserialize. You know, I'm going to move my harness to just harness.rb. Terrible name, but I'll remember it easier. So the harness is actually okay with that. What if we get rid of both the equalses into harness? Still happy? What if we start to just brutalize the base 64? Still happy? Very tolerant of a base 64 decoder. There we go. So eventually we get a JSON parser error. The base 64 was fine. A very, very tolerant base 64 decoder. Okay. In that case, let's just do one begin, rescue, end block. We don't need to kind of separately handle... I mean, we shouldn't be getting corrupt base 64. We'll be mindful to only give valid base 64. So we should be all good. So for line in lines, do begin, rescue, end. So in the begin, let's just puts the line, so we can see in our output what's happening. After the end, we'll put our dashes. Rescue puts. Puts doesn't need brackets, does it? No. My head's stuck in Python land. So inside the rescue, whoopsie whoopsie, a fucky wucky happened. And we'll revisit that in a second. So now if we run this thing that just blew up, we get what we tried to deserialize and oopsie whoopsie. So then the script continues, right? So this was good, except I've renamed the script. So that line deserializes to hello world. That line deserializes to hello 2, 1, 2, 3, 4. If we break that first bit of JSON, get rid of this end quote here, then yep, that one results in an error, and this one is fine. So we've got exception handling going on that will let our script soldier on even when we throw it bad stuff. Now, instead of this silly error message, how can we actually report on the exception that occurred? So we can do rescue. The type of error as E is how I'm reading that. Then we can puts the e.message and puts the backtrace. We don't really need a backtrace in this case, but the message might be cool. Now rescue standard error. What was the base class of errors? Okay, it is a standard error. Good. So if we just go and rescue the standard error, we should be rescuing from every possible exception type. And we can put the message. I like it. So we want to rescue, was it standard error? Yep. As E. And we want to put E dot, was it E dot message? Should have read it. E dot message. All right. Let's try that. Yeah, so this here, we get unexpected token at hello world. I like it. And this one here deserializes just fine. I don't know what this single quote's doing hanging out by itself, but anyway, whatever. On error resume next, exactly, serializing. That's actually exactly what we're doing right now, is essentially we're catching and swallowing errors, which by the way, this is a horrible pattern. Be very, very, very careful whenever you're doing this. You should only be doing this when you want your program to proceed in its crack-headed way, because if you've got errors happening and all you're doing is printing out what the error was and YOLO continuing, whoever becomes responsible for your code after you, or you in 6 months' time, will be very angry at yourself. I do have this pattern in my code, but I'm kind of careful where I put it. And I make sure I scream bloody murder so that in the log files I can see that I've got some edge case I'm not handling well, and my code isn't exactly production grade, it's just little toys for my use, so be very careful about this type of pattern. But for our purposes, this is perfect. We can go and get standard input, split it on the new lines, and then for each of those lines, we just print the line so we can refer to what input was given in our output, and then we base 64 decode it, which lets us more gracefully spray nulls into this thing. We try to JSON.parse it, and we try to print the result of that. And if anything in here results in any sort of error, we just print the error message, and then we print some dashes, and we continue going through the lines. Caught error message, you should not be seeing this. Exactly, well, plenty of those in my code. So, I mean, the code's done, the harness is done. Now we get to play and try and figure out how we can trick Ruby into accepting JSON with nulls in it. So I'm going to take another quick 2-minute breather. I need to fill my water bottle up. You should too. Make sure you stay hydrated. And we'll be back soon to figure out how to get nulls past the Ruby JSON deserializer. See you soon. Alrighty, we are back. We've got our little harness going that tells us whenever we have some illegal JSON coming in, and otherwise it tells us what it deserialized to. So now we can start playing around and try and figure out how to squeeze some nulls past this thing. So I'm thinking we do Python 3. People are going to be so angry at this, by the way. I don't want to Ruby so much that I'm just wiring up Python to Ruby so I can do my thinking in Ruby, thinking in Python while fuzzing Ruby's JSON parser. The other thing we can do is we can Google, like we started doing last episode, how can I put nulls in Ruby's JSON.parse? But I think it might be fun to try and fuzz it ourselves. Call me crazy. So let's do Python 3 minus C, import JSON, and then do JSON.dumps hello world, right? So let's do import JSON, import base64, print base64.b64 encode JSON.dumps hello world, unterminated string. Where did I go wrong? Python 3 minus import JSON, print 1, 2, 3, 1, 2, 3. Base64 wants a bytes object, so dot encode UTF-8. Oops, that was a typo. There we go. Okay. We want to print that. Dot decode UTF-8. Can't type at all. Decode. Oh, come on. Okay, this is obviously not the right way to do this, is it? No, it's not. Vim give input.py user bin and Python 3. Start again. Import JSON. Import base 64. My object equals hello Twitch. And then we want to what do we want to do? My obj JSON equals JSON.dumps my object, and then we want to my obj JSON base 64 equals base 64.b64 encode that encoded as UTF-8. Everyone who is bashing Ruby probably feels really stupid right now. I know I do. Let's just print that and see how we're tracking. Mod u plus x give input. Okay. Now we want to print that decoded as UTF-8. That looks better. So now if we go give input and pipe that into the harness, we can see that our Python code gave that input and Ruby saw that pop out. Hello Twitch. Now what we could do is we could do something like this. My object JSON is that, which is a string for I in range, bear with me for a second, 10. My object JSON equals my object JSON.replace Twitch with Twitch something I. Right, so we will, inside of our loop, we'll be replacing Twitch with Twitch 1, Twitch 2, Twitch 3, Twitch 4. Then we will... okay, I'm reusing a variable. I shouldn't be here. My object JSON fuzzed equals that. And then my object JSON fuzzed base 64 is my object JSON fuzzed encoded and then base 64 encoded. Then we want to print my object JSON fuzzed base 64. Serializing, I think I am replacing on a string because I'm replacing on my object JSON, and my object JSON is a JSON.dumps, which is a string. You'd be correct if I was doing a dot replace on my object, but it's on the JSON representation. Good catch though. And this is an awful way of generating fuzz mutations, but maybe it's going to work. I don't know. So now if we run give input, we get all these new lines separated. Do these actually change? Yes, they do. That bit there is changing. Cool. And if we pump that into the harness, we can see that this one deserializes, decodes, and then deserializes to hello Twitch 0, hello Twitch 1, hello Twitch 2. All right. So we've got the ability to, in this case, like dynamically generate input and feed it to the harness. So that's kind of cool. So now for funsy, let's instead of replacing Twitch with Twitch a number, we can replace it with Twitch null byte a number, right? And these all fail. Let's just, for giggles, echo that into base 64 to code. Yeah, okay, so we're generating hello Twitch, that's the H, that's the null byte, and then hex 30 is 0, double quote, squiggly. So that's good. This is kind of interesting error output. Unexpected token at hello Twitch. It's almost like there's... It's actually almost like there's truncation going on here. And that's not the same error we were seeing last stream. I don't think it was a matter of truncation. I thought it was UTF-8 nonsense. What if we just run that there into head and 3? We'll get the first 3 lines and we'll just hex dump that. Is there stuff we're not seeing? Unexpected token at hello Twitch. There's our double quote, TWITCH, single quote, new line. Yeah, serializing. I thought we were getting slightly different output last time though in IRB.
Yes.
And that's Siri thinking she can help us and she cannot. Import JSON. Require JSON. Require base 64. If we just puts base 64 dot code 64. This is what we were doing last stream. Let's go and grab that one there. So that's hello Twitch 9 and there should be a null byte in there. And if we wrap this in, is it JSON.parse? Okay, no, this is the same error we were getting a second ago. You know what? Let's comment all that out for now. Let's get a test case from the last stream that we know was causing an error. to do with that if I recall correctly, was causing error to do with UTF-8. So let's decode this as URL and then encode it as base 64. In fact, we don't even need Python anymore. But what I'm going to do is I'm going to throw the privacy screen up because my clipboard has been playing up. Okay, no, my clipboard is fine. I'm paranoid now after spilling that password last episode. Echo-n that into the harness. I could have sworn we were getting different errors last episode, weren't we? I thought it was UTF-8 stuff. Am I going crazy? Rightio, okay, serializing me. I must be going crazy. Trying to think, is it worth me going through just for my own curiosity? I think I want to have a look at a stream last week's last episode. How do I find the biggest file in this directory that actually is the stream that I want? Let's go to the renders. I'm on my local machine here. Videos, renders, stream. Okay, so I'm just going to scrub through here. Yeah. I think I can share this if I just go stream whole desktop. Do I have anything I don't want to share? I think I'm all good. I was doing, but I wasn't doing puts. I was just doing JSON.parse base64.decode 64, and I was getting, IRB was blowing up because invalid byte sequence in UTF-8. Then again, there's nothing in this trace that's actually inside of JSON. Anyway. Let's go back to the VM. IRB. Acquire JSON. Acquire base 64. Instead of doing... Hang on, that's a... Instead of doing the puts stuff, let's just do this. Usually the first character is hexade and that results in invalid UTF. Where is burp? What did I just copy? Yeah, there's my hex 80 there. This is it here. Copy that. Base 64. Base 64.decode 64. Let's go and puts that. We get username, literal double quote, curly, and then in here there should be all the noise. Because the number of backslashes here concerns me. It should be fine. I think it parse failed earlier than the hex 80. If we get this here and go JSON. Yeah, window just slammed. JSON.parse that. Now we're getting that. What's going on? Yeah, IRB is actually getting dumped as well. Okay, so I'm not going crazy. We were looking at a different type of error last time, but maybe that's actually IRB getting cranky, not JSON. I don't know. Maybe it's just a distraction. Maybe we shouldn't care so much. Maybe we should just keep playing with this in the hopes that we can find a way to get these null bytes. Actually, there's a hex 80 then a null byte, so maybe that's a more fair test. Let's go and give the input to the harness. And yeah, we're getting unexpected token. So now we need to find out how to get, yeah, JSON.parse happy with this. And I've been thinking the last couple of days, and I don't think it is this, but is there a thing to do with byte watermarks that we can use to maybe get us out of the woods? Because I don't know if a byte watermark has to go at like the top of a document, or if it can be halfway through some input. I don't know. It's got to appear as a magic number at the start of a text stream. Then again, we can put it at the start of the text stream because we are controlling the dangling of the JSON. So if bomb appears in the middle of a data stream, Unicode says it should be interpreted as a zero width non-breaking space. But we can put it at the start, I think. So the UTF-8 representation of the bomb is EF, BB, BF. Yeah, but serializing, we can put it at the start, right? Sorry, I'm not talking about at the start of curly username. I'm talking about at the start of, like in here, if we can put it before our whack. I don't know if byte order markings actually make sense in a JSON value. It's just a crazy idea. I was thinking in terms of what could we use to change the way in which our string is being interpreted. Byte order markings came to mind. It probably won't work, but it's just an idea. I mean, we can just put it in and I guess see what happens. So we want to replace Twitch with this. Hex EF, hex BB, hex BF Twitch, then the hex 8000. I mean, it seems satisfying. What if we do that and get rid of our hex 8000? It becomes part of the string. I would have thought that a byte order marking, I don't know, kind of would have hoped it would have gone away, but maybe it needs to stick around so that the byte order marking remains attached to the string. What if we edit our harness? Vim, give input and the harness. How about inside of our rescuable stuff? Parsed equals that, and then puts parsed, and then puts parsed hello. What if we actually reach in and then try and print out that value as a string? Yeah, so we get these 3 underscores. I mean, I don't know. I kind of don't like that as being an indication we're actually changing the mechanics of the parsing. Let's just comment that out. That might come in handy later on. Yeah, I don't love it. I don't love it. What if we, instead of that, we replace Twitch with hello? We have to bring back the hex 80 hex 00 here. We'll just do it here as well, so we've got it there if we need it again. Whoop. There we go. So what if we actually fuzz the key instead of the value? Instead of fuzzing this part here and whatever. We're not really fuzzing at the moment, we're just going and triggering the unhappiness. What if we trigger the unhappiness in the hello instead? It's just as unhappy. Just as unhappy. What else could we do? I mean, is there any sense in, JSON byte auto marking? Is it marking or mark? Byte auto mark. The bomb character is illegal in JSON and not needed. Implementations must not add a bomb to the beginning of JSON text. I think this is to do with being at the start of the actual JSON document, not halfway through. Is it worth reading the actual RFC for JSON to see what other knobs might be exposed to us? This is all looking pretty vanilla so far. I realise this is probably the most boring thing we could be doing, but bear with me just while I have a quick flick through the JSON spec to see if anything nothing's jumping out at me so far, or I'd be chatting about it. But let me just continue leafing through here. If this is as boring to you as I'm guessing it is, perhaps make sure you're hydrated, get yourself a glass of water or an ice cream or something, and otherwise just bear with me. I think this is kind of maybe where we're blowing up as well. That's when you literally whack you something nonsensical. We're not even doing the whack you. We're not being as polite as that. We're just throwing literal null binary bytes into the stream. So it's probably actually not what we're brushing up against. Well, that actually doesn't help us at all, does it? Nah, that's no good. Trip and Flare, I'd love to ELI5 a CTF. A CTF is a information security, computer security, cyber security, or hacking game in which some intentionally vulnerable software or an intentionally vulnerable computer system is made available to the player, and the player has to find the vulnerability in that computer or in that program and exploit it. So you have to find the vulnerability, and then you exploit it to actually hack into that thing. And once you do that, you typically get shown something that looks like this. It's called a flag. That's the F in CTF, capture the flag. You need to capture strings that look like it. It's much more exciting than I'm making it sound, but you hack into a thing to extract the flag. So in this case, we already know what the flag is going to be once we break into it. This is an old challenge that has been published by a company called Elttam. But we're having a look at, and we're like a million layers deep at the moment right now, we're having a look at Indigo Birdie and trying to find out how to log in as admin without actually logging in as admin by exploiting a security hole. At the moment, we're doing, funnily enough, what a lot of hackers end up having to do, which is to read documentation and understand. Yeah, I know, right, Volvin? Much more, yeah, pretty much. As computer security professionals or as hackers, you often, like, it's not as sexy as it's made to sound. You do spend a lot of time just reading the documentation, reading the manuals, reading code, scratching your head going, I don't know what's happening, until finally you have that eureka moment when you're like, aha, now I know what's happening. There's either some weird peculiarity about the specification of a protocol, or there's something wrong in a program, and then all of a sudden you feel like an absolute hero and you can hack anything and hack the planet. But until then, it can be mind-numbingly boring. And now we're reading the Wikipedia page on JSON to see if we can find some edge case that lets us do what we're 1,000 million layers deep trying to do, which is to have Ruby parse JSON that contains nulls. And I feel like I'm putting myself to sleep here, so thank you for everyone who is sticking around right now and bearing with me through this. Alright, what have we got here? Yes, it does, trip and flare. We could probably go read the code for that as well, we probably couldn't go read the code for JSON.parse, but yes, Ruby does. It is required JSON.parse. So we probably could go read that. Let's keep fuzzing the value. Okay, now I'm really trying hard. Let's just go and replace Twitch with, and let's just go and chuck in every single byte before the hex 80 null and then a number. So we're going to go, oops, let's get rid of this number at the end here. So we'll go Twitch and then every single possible literal binary byte from hex 00 to, which won't do us any good, up to hex FF. And just, I guess, see what that does. You know what, let's, in our harness, if we manage to calculate parse, let's just put winner. Grep winner. No good. So throwing all the bytes out, it didn't work. No, it looks pretty boring as well. Ruby GitHub. Find file, JSON. Ext JSON lib JSON.ruby. Look at that. Ext JSON parser, parser.c. I really like that. We've got a doc string here. This actually might be worth reading. Just this doc string even. Parsing JSON. Nah, it's not that exciting. Oh, the code is generated using Regal. Lovely. Beautiful. So we've got something here, unescape Unicode. Sounds somewhat interesting. Convert between the UTFs. Okay. JSON parse object. Whinging about nesting being too deep. Interesting. Maybe we need to read the actual Regal code that generated this C code. There's a lot of go-tos going on here. I don't like it. RL, is that Regal? Okay, this looks like it might be a little bit better, maybe. C comment? Okay, so why does the Ruby JSON parser know what a C comment or a C++ comment looks like? Does Ruby's JSON parser allow comments? Just a really quick check of that. IRB JSON. Is it JSON.parse with a small p? Yeah, I think so. Hello world. Right, okay, so require JSON. Okay, so now inside the curlies, slash star star slash. Excuse me, what? ASDF. Okay, right. So @Wolf said before, isn't it a shame that JSON doesn't have comments? Was that, were you being cheeky there? All right, inside of our Python, let's just get rid of our fuzzer mess and print hello world and give that input to the harness. Unexpected token. All right, you get a pass at Wolf for no spoilers. What is wrong with my give input? What am I doing? Hello world. Okay, am I missing something? What's wrong with this JSON now? Hello colon world. Echo that into the harness. Do I just have a syntax error in my harness now? Puts winner, puts parsed. Oh, I need to base64 encode it. Yep. Whoopsie. So we need to print. Oh, yuck. We're back to where we started before. You know, I'm going to bring my loop back. I'm going to take it out of the loop. Delete that. I think we need that back. So we need to do our replace. We'll replace Twitch. Okay, kids, never do this at home. This is an awful hack. We're going to replace Twitch with what? Twitch actual. No, I don't like it. I'm going to do this the right way. My string equals hello world. And then what do we need to do? Base 64 it. Now we need a my string JSON equals JSON.dumps. No, it's already JSON.dumpst. So that's actually my string JSON here. Cool. And then my string JSON base64 is base64 encode my string JSON encoded as UTF-8, then encoded as base64, and we just print this here, right? Give input to the harness. Oh, what's wrong? Need to decode this, don't I, as UTF-8. Okay, the Python now has a syntax error. There we go, good. Okay, finally, good. Okay, so we got a winner because this legally decoded. Now, let's just go and, no. Oh God, C comments. slash star ASDF slash star. No. Star slash, good. Yep. Okay, there we go. So we can have a comment there. Instead of ASDF, can we have our hex 80, hex 00? If this doesn't work, I'm going to look real stupid. Okay, now Ruby looks stupid. So Ruby lets us have comments in Y. Like, am I crazy or is that just a bit weird? What else is in the Regal code for this? We've got comment is C comment or C++ comment. So C++ comment is a slash slash. C comment is slash star star slash. Nans and infinity, are they legal in JSON? Maybe they are. Yeah, at Wolf, serializing is kind of like %n in the format string world. Like, why do we even have this? This feels dangerous. JSON Ruby comments. So Crockett has a reason why he removed the comments from JSON. Why did Ruby go and put them back in? Is this even really like known and talked about or not? Is this even documented? Yeah, right. Like, and I kind of feel a little bit bad for not just trying this, but at the same time, I kind of don't feel bad because this is just weird. This is just the doc string we were reading a minute ago. Control F for slash star, nothing, slash slash, nothing. Comment, nothing. How bizarre. Alright. Well, what are we going to do with it? Because I'm guessing you can't have a comment inside a string. We've got to get ourselves outside the string context. So the username is going to be double quote begin C comment. And then the application will bring to the party double quote curly. But it doesn't matter. And then padding. And then we can bring star slash to the party. Comma space username admin, and we should win, right? So username is going to be double quote to get out of the comment, to get out of the string, slash star to kick off a C++ comment. C comment, C++, I think it was the C++. Yeah, CPP, no, C comment. What a nice toy. So post double quote forward slash, that's a 2 F's a forward slash, yeah it is, star, and what do we get back? Session data is this, send to decoder, decoder's URL, username, what have we got? Username is begin string, end string, begin comment, garbage, cool, I like this. Let's grab that because that goes into our hash pumpy script. I'm going to just tear a few things down here so I don't get too lost. Cool. Okay, so here's hash pumpy. Inside our call to hash pump, we have this. And that's fine. Nothing in here needs escaping. Python should be happy with that as a string. Cool. And we're going to pad it with... Whoops. We're going to pad it with... there's going to be a whole bunch of padding involved in there. Then we're going to have star slash single comma username drop in this hash we got given for hash pumpy's sake. Right, so hash pumpy is going to, for all the possible lengths of the secret, which is honestly, I think I've already figured out by scrolling through here way more than we need to be doing, but anyway. We're going to get a new hash and a new username. Hash pumping it with the hash. Username, we've got a key. A value being empty string. Start of a comment. Trailing garbage. Hash pump will have padding in the middle. Close off the comment. Comma. The new username is admin. So this, previously we were hash pumping to just try and prove the concept of this being pumpable, but now we're actually going straight for the jugular. Like, if this works, we should actually, in burp, get a flag somewhere, which is kind of cool. If try access that, print win. Have I got this the wrong way around? If try access. Shouldn't that be if not try access? Anyway, we'll just probably fish it out in burp anyway, but try access takes session data, session hash, and we're just literally dropping them in, so that should be okay. I'm just gonna run this. I'm feeling lucky. Oh, I saw a little flutter there where a hash seems to have changed. Wolf, I agree. And a little birdie told me as well, let's just do this into sort unique. A little birdie told me as well that no one solved this on the day. So yeah, it should be more than a medium, I agree. Especially because it's so blind and interesting. We got 2 hashes. Oh, it just destroyed it. Yeah, you have to jump through a lot of hoops here, Wolf. And you got to do it blind as well. Without Bitcoin CTF giving us a hand, I don't think I would have found this. Yeah, 2 hashes in the output. So in burp, which one has a different content length? We've got 955 all the way through here. 1019 content length. The request had a hash that looked like that. Session data looked like this. Suspense, I'm building up, and if it didn't work, I'm going to look real stupid. Username empty string. Comment with some noise. And then username admin. The response. Welcome admin. And there's our flag. We're done. We are free from the Insatiable Birdie series. That's a cool challenge. That is really nice. Thanks, Volvent. Thanks, Serializing. Thanks, Wolf. Thanks, Dr. Satoshi Cesare. Were you Dr. Satoshi Cesare the whole time and I was just reading it as Dr. Silvio Cesare, or have we got 3 Silvio wannabes in chat? Men's, thank you very much. That's cool. That's cute. Okay, I don't know what you're saying yes to there, Dr. Satoshi. Wolf has the stream dying. Silvio's here too. Thanks, Silvio. I don't know who to believe anymore. Dr. Satoshi. I don't know how many Satoshis we've got and Silvios we've got, and anyway. Awesome. I'm super happy with that. That's a cute challenge. So, to recap, it was a poor man's MD5 HMAC that was hash paddable, but we were getting no response out of the server when we tried to hash pad it because illegal JSON gives you pages that look like this. Whether it's a hash failure or a bad JSON deserialization, you got the same error message. You got no error message. You just got the login page, basically. So, like, I guess my feedback for this level, to make this easier, what would have made this easier would be some sort of differentiation here, even if it's an error message that just said illegal JSON or JSON failed or corrupt if there was a message here that just said corrupt session data when you got the session hash correct, but this resulted in a JSON parser blow up, like that would have made this way easier. As it was, you had to, and to be fair, I should have probably done this. You had to think of throwing your candidate session datas at Ruby to see that it was blowing up on a Unicode error, which, to be fair, I probably could have done. I probably should have done. I shouldn't have just been blindly YOLOing things. But once you realize that's the trick, you then start thinking, as Bitcoin said last stream, how can you get away with putting nulls in JSON and having Ruby eat it? And the answer turned out to be comments. And I can't remember who it was. That I think it was whoever said, is there a standard JSON library for Ruby? Maybe you were asking because you're like, maybe the server's using a different library, in which case that would have made this challenge even more of a ball ache. But that gave me the idea to actually go read the code, which, you know, between reading the RFC and reading the code, it's, you know, underappreciated and no one really wants to do it. But when you do it, I can't even see where this is documented, but in the Ragle code, and Ragle is like a language that you can use to write C code, if that makes sense. I think Ragle is a language that gives you like a finite state machine program, maybe. I'm swimming outside of my lane here, but like this code here defines a state machine, and you compile this code with the Ragle, I think you might call it a preprocessor, and then Ragle outputs C code, and it warns you this file is automatically generated from parser.rl by using Ragle. And you get code that's, you know, full of go-tos and switch statements and stuff that... This is the compiled version of Ragle, which is essentially the C code that implements the state machine. But, you know, it was by reading the Ragle code that this, and as soon as I saw this, and Atwolf, as you said earlier, if only JSON had comments, this would be much easier. JSON doesn't have comments, and maybe some reading when you're at home is to find out why. I'm going to find out why. I can't remember why JSON doesn't have comments. But Crockford, the inventor of JSON, said, I think he's probably got some excuse or some reason why. But then Ruby went and just YOLO'd the comments back in there, which is nice. I mean, I think JSON would be nicer with comments, but it gives you an interesting exploitation primitive. So once we saw this, we then did a hash pumpy over a hash we'd gotten out of the service and a JSON injectable thing we'd gotten back from the service that left us dangling, not in a string context this time, but in a C++, or I think it was a C, in a C comment context. And then all the padding got trapped inside the comment, and we then hash extended it with closing the comment, username equals admin. And then, as I suspected, Ruby, when it deserializes JSON and there's key collisions, it takes the latter key. It takes the latter key's value. So it's kind of like we were able to overwrite this username empty string with a new one using hash padding. Serializing had the same reaction. Serializing, did you end up at the same place as me? Were you reading the Ragle code for Ruby's parser? Because if so, that's kind of beautiful. That's kind of cool. We ended up in the same place. Serializing, how did you find out that Ruby supported comments in JSON? Atwolf's kind of pissed. Dude, be proud of that. That's good on you. That's some really great foreshadowing right there. Yeah, cool. Serializing. Did you read the code? Did you find some documentation? Did you find it on Stack Overflow, or did you just try it dynamically and end up with it working? Yeah, cool. Bitcoin's a great dude, hey. He's a super good dude. Okay, so serializing, you read it in the code as well. Very cool. Alrighty, I think we can call that a stream. I'm pretty happy with that. So this is part 3 of 3 of the Elttam Insatiable Birdie series. Thank you so much, by the way, to Elttam. This stream isn't associated, affiliated, sponsored by, or endorsed by them. They've been retweeting my stream recordings, and thank you very much to the Elttam crew for that. But this was me doing this off my own bat. I thought there would have to be cool challenges because I know that there's cool people who work at Elttam. So thank you very much, Elttam crew, for publishing these challenges. Thank you very much, Elttam crew, especially Bitcoin CTF, for your assistance, support, and hints and help and encouragement throughout this journey. Thanks to you all for sticking around with me on Twitch. Thanks to everyone who's been watching on YouTube. And I think next stream, I haven't decided for sure, but maybe we want to stay in the crypto lane. Maybe we want to pick up the Crypto Pals series. Selfishly, it'll help me get affiliate because I can afford to do many of short streams to get to my 8 streams or 7 streams in 1 month. But maybe it'd be cool to kind of stick with crypto. I'm not that great at crypto, and going through and actually building up encryption and decryption and breaking it from some building blocks could be good. Silvio's been playing with Crypto Hack. Again, Silvio, I don't know if it's the real Silvio, but cool. I've heard of Crypto Hack as well. I got like halfway through Crypto Pals a few years ago, so I'm kind of keen to revisit it, mostly because I know I can do it, or I can do the stuff that I did a few years ago. I've forgotten it, but I know it's doable. So I reckon that could be good fun. So maybe for the next little while, it'll be a little bit less of the computer hacking and a little bit more of the computer programming. But being able to write code is important. Being able to do crypto appears to be important. No one wants to do it, but it seems useful. So maybe we'll do a series of computer programming instead of computer hacking, but with a kind of an underlying theme of computer hacking and crypto still. So thanks very much, everyone. I'm going to call it a stream. I'm going to go tuck into my chalky eggs. For those watching on YouTube today, is Easter, so I've got some chocolate to go make myself sick with. And I'll see you all in the tubes. Cheers.